All right, so welcome back. Today we're going to multiply imaginary numbers. In our last lesson, we took a look at adding and subtracting as our operations with imaginary numbers, or I. So in this first example, we're just reminded what I represents. And of course, I represents taking the square root of -1, which normally we would think about that as, how do I take the square root of -1? That means a number times itself that equals -1. That's not possible. Well, it's not with real numbers, but it is with the imaginary number we call I. Okay, so we also said that I squared equals -1, and here's why. If I were to take I squared and write it out as I times I, in other words, the square root of -1 times the square root of -1, I would be reminded that just like when I multiply the square root of 3 times the square root of 3, I get the square root of 9, which is 3. Okay, so again, I get this number in the radicand as my solution when I multiply it by itself. So the square root of -1 times the square root of -1 is just -1. All right, so there's a little rationale for why I squared then equals -1. So let's take a look at how we multiply these imaginary numbers down below, 3i times 2i. And keep in mind, 3i represents a multiplication already, like 3 times I times 2 times I. So what we can do here is use our commutative property and kind of regroup and rearrange our numbers and put our real numbers first, 3 times 2, and then our imaginary numbers after that, I times I. I still have the same four things being multiplied together, just they're regrouped appropriately. So I multiply what I can. Well, 3 times 2 is 6, and I times I, of course, is I squared. So we have 6 times I to the second power. And remember up above, we said I squared is -1. That's going to be very helpful today. So if you can memorize that or write it down as a reminder, I squared equals -1, we're going to use that a lot. So anytime you get I squared in our work, like we did here, we can actually just replace it with -1. And of course, 6 times -1 is -6. So 3i times 2i is actually just -6. Kind of cool how that works. I multiply two imaginary numbers together, I get a real number, -6. All right, so here are some examples where we include these radicals with negative radicands. Let's go ahead and multiply these. However, there is a little rule that if you have the square root of a negative number, we have to simplify the I first. So let's do that with each of these radicals, starting with example number 5. So we have the square root of -20. So what I'm going to do is just begin by writing it as the square root of -1 times the square root of 20. And I know that the square root of -1 is I. And you know what? I'm going to leave the square root of 20 as it is for right now. I could probably simplify that and break it up as square root 5, square root 4, but let's leave it as square root 20 for now. Let's do the same thing with the square root of -5. That's square root of -1 times square root +5. Okay, so I split up each one of those. And look at that. I have another I right there. Okay, so I've got my eyes. Basically, I poke the eyes out, and I'm left with square root 20 and square root 5 as well. Now, if I regroup those, I have I times I. So I multiply this I times that I, and of course, that gives us I squared. And then if I also regroup and multiply my square roots together, use my product rule, the square root of 20 times the square root of 5 is the square root of 20 times 5, which is 100. Oh, good. Look at that. The square root of 100. We know that. That's just 10. So that's 10. I squared. Do you remember what I squared equals? -1. And when we multiply -1 times 10, we get -10. So the square root of -20 times the square root of -5 is just -10. Let's try number 6. The square root of -5, let's begin again by kind of poking the I out, get that -1 out of there. Square root of -8, let's do the same thing over here. So square root -1 times square root of 8. And I notice I have my I's. So I'm going to multiply together my I's. I'm going to multiply together my square roots. And let's see, I times square root 5, I times square root 8. And of course, we know I times I is I squared. That's that part. And the square root of 5 times the square root of 8 is the square root of 40. And you remember what I squared is the same as? What does that simplify to? Just -1. I times I is -1. And then in this case, the square root of 40, we can simplify that. It's not a perfect square. I can't change it to a whole number, but I can write it as square root of 4 times square root of 10. Since 4 times 10 is 40. Square root of 4, square root of 10. And of course, we know that the square root of 4 is 2. So we have, so I can write this all in one line here. -1 times 2 times the square root of 10, which becomes -2 square root of 10. So I multiply my whole number of parts together there.